Hello everyone, today we will discuss a binary tree problem, lead code algorithm problem 1110, delete nodes and return forest. Firstly, let's see the description of this problem. Given the root of a binary tree, each node in the tree has a distinct value. After deleting all nodes with a value in to delete, we are left with a forest, a disjoint union of trees. Return the roots of the trees in the remaining forest. You may return the result in any order. Okay, let's see our solution. We use a recursion solution to solve this problem. To delete a node in the binary tree, we need to pass the information from the children nodes to the parent node to tell the parent node its children node will be deleted, and then to decide whether a node will be a root node in the final forest, we need to let the parent nodes to tell their children nodes that their children nodes will no longer have parent node, so the children nodes will be the root nodes for the trees in the final forest. So, which means in this problem, we need to pass information from parent nodes to children nodes, and we need also to pass information from children nodes to parent nodes. Here is a rule for pass info downwards and upwards. So by using the arguments of the recursion function, so the argument is the node exists parent, something like here. The parameters of the recursion, we call them arguments. So if we need to pass information from parent nodes to children nodes, we will use the arguments or parameters of the recursion function. And if we want to pass information from children nodes to parent node, we need to use the return value of the recursion function. So the return value is like here we return none, we return node, so the node or none will be the return value of the recursion function. Okay, let's see our recursion function. We use a Python list to store the final result, that is the trees of the forest. And we use a Python site to store the to delete list. We use the set because the set in the set we will not have duplicate items, and the time complexity to find whether an item is in a site is only 01. So that's why we use the set, because when we want to reduce the time we need to check whether any item is in the site. Yeah, let's see our recursion function. Firstly, we will deal with how to pass information from children nodes to parent nodes. That is, we need to decide what to return in the recursion function. So firstly, if the current node is none, then we need to return none. And this is a corner case. And the other one, we need to find out whether the current node is in the to delete list. So if the current node is in the delete side, so we will have the node dot value, and we check whether it's in the delete side. So if it's in the delete side, which means current node will be moved, and then we need to tell the parent of this node that the previous children nodes need to be replaced with null node. So if the current node is in the delete side, we will just return none, and we will this null will tell the parent node that its previous children nodes will be deleted, and for the parent node, its previous children nodes need to be replaced with a none. And else, so if the current node is not in the delete side, we just return the node. And then we need to deal with how to pass the information from parent nodes to the children nodes. So we will use the argument. Also, we call these parameters in the recursion. So it is a Boolean parameter, exist parent, which means whether for a node, whether it has parent nodes. So if there's no parent node, which means the current nodes need to be a root node in the final forest. So we will say here if not exists parent, so which means for the current node there is no parent node, and then we need to append the node into the final forest because it is a root node for a tree in the final forest. And we use the we call the recursion function to pass the Boolean parameter exist parent to its children. So here we have recursion function, and for the parameter node we have node dot left, and we have exist parent false, because for the current node is in delete side, so which means the current nodes need to be removed. And then for its left child, the left child will not have a parent node after this current node is removed. So we have exist parent parameter to be false. And similarly for the current node's right child, we also need to pass the right child node's parent will not exist, so here we have the exist parent false passed to the right child. And if the current node is not in the delete side, we will pass the exist parent parameter to side true for the left and the right children. So by this ways we will successfully pass information from parent nodes to children nodes, and to pass the information from children nodes to parent nodes as well. And then we call the recursion function and set the initialize information as the binary tree's root node, and for the entire for the root node of the entire tree, we will set the initialize Boolean parameter exist parent as false, because for the root node of the entire binary tree there is no parent nodes. And after recursively call the recursion functions, we will traverse the entire binary tree, and for each node we will traverse only once. So the time complexity is O(n), and and the space complexity is also O(n). Yeah, it's not There's no special corner case for it. And then we return the result. And let's submit our solution. Yeah, accepted. So the solution is accepted by the lead code, which means our solution is correct. Yeah. Let's finish our discussion today. Thank you so much for your time. See you.